In 11a, we're going to be talking about rational expressions. A rational expression is a fraction in which both the numerator and denominator are polynomials. So to reduce fractions, you're going to find common factors in the numerator and the denominator. So 24, when we do that now, we look at it and we think what it might have in common. And you may be accustomed enough now to say that 24 is 12 times 2, and 60 is 12 times 5. So we may recognize that, and then what we'll do is we'll find the common factors and then say that 12 over 12 is a 1, and then we're left with the answer 2/5. We could have also broken that down into total primes where we had 2 times 2 times 3, 2 times 3, and 60, the same thing, 2 times 2 times 3 times 5, and broken it down. 15 over y, we might say, is 3 times 5 times y, divided by 25, which is 5 times 5. And then let's just write it out as y times y times y times y. Then we can cancel that. So again, 3 over 5 is not going to reduce, but 5 over 5 makes a 1. And then y over y also makes a 1. And what we're left with then is a 3 in the numerator and 5, and then y times y times y. So 5y to the third in the denominator. So we can reduce our fractions that way. So to simplify a fraction with polynomials, you're going to factor the numerator completely, factor the denominator completely, and then cancel factors that are common to both, just like I did above in those examples. So now let's talk about factors. So which of the following polynomials have more than one factor other than 1? Well, 2x plus 3 has, what is 2x and 3 called? That has 2 terms, because they're separated by a plus. So there's 2 terms, but there are no other factors. So 2x plus 3 only has 1 factor, and I'm going to erase this right there. So 2x plus 3 only has 1 factor. Now 3x plus 6 looks very similar to it, but it has a GCF of 3. So I actually can factor out a 3 there and be left with x plus 2. So this one has more than 1 factor, so there's 2 factors here. C, again, I can factor out an x, and it'd be x plus 1. So there are 2 factors here. X squared plus x plus 1, now I would have to think the AC method. But 2 numbers that look multiply to be 1 and add to be 1 don't exist. So this one has, although it has 3 terms, it only has 1 factor. X squared minus x minus 2. Now there's 2 numbers that multiply to be negative 2, which would be negative 2 and 1, that add to be negative 1. So this actually factors into x minus 2, x plus 1. So there are 2 factors. So x minus 2 is the first factor, and x plus 1 is the second. And x squared minus 9 does not have a GCF, has 2 terms. And remember, the other way to factor 2 terms is x minus 3 and x plus 3. So again, there are 2 factors here. So example 2 says to describe the error in the following work. Here we have 3 plus 12 over 3 plus 15. And then we have our 3 over 3. So yeah, that makes a 1, right? So those are canceling to be 1. You get 12/15. And that reduces 3 going to 12 4 times, and 3 goes into 15, 5 4/5. But is that right? 3 plus 12 is 15. 3 plus 15 is 18. And then I could divide it by 3, both of these, and get 5 6, which is not the same here. So what was wrong? Well, here we didn't have factors. We had a sum. We cannot cancel. You cannot cancel terms, which means that there's a plus in the middle right there. So you cannot cancel if there's a plus or minus that's combining the two numbers. All right, so this next one, example 3, asks us to correct it without finding the sums like I did in example 2. So what could I do? Well, I can look at 3 plus 12 and see that they have a factor of 3 and do it a GCF. So if I took the GCF out, I'd do 1 plus 3 going to 12 4 times. And then factor out a 3 in the denominator, which leaves me with 1 plus 5. So that's going to be 3 times 5 and 3 times 6. And there you see now I have this in factor. I have it in factors. So it's now multiplied, and I can now cancel and get that 1 right there. And my answer is 5, 6. So get the idea. If they're multiplied, we can cancel them. But if they're added, as they are right there, we cannot at that point.